So Dave gave us a great title, Towing Tank Experiments of the 6-1 Prolate Spheroid at the U.S. Naval Academy. And so we started on some preliminary measurements about a year ago. We took those measurements over holiday break this last semester, and we're ruminating on the results. We are preparing for a slightly downscaled version of the preliminary experiment in the near future, basically starting next week and moving through the rest of the summer and into the fall. And we're gonna try out some ideas and get set up in the recirculating water tunnel, which I'll talk about here in a second. And the idea is that we take what we learned from that and we move it out into the towing tank. And hopefully by that time, there'll be more opportunity. The towing tank takes a lot of personnel to run, and that's not a very feasible concept at the moment. So hopefully by the time we get to that point, we'll be in a position where we can get everybody into the carriage control room, etc. So our previous work here, we did PIV measurements in the wake of a spheroid that was being towed by a stationary system as it went through. And we did that for Reynolds number of 500,000 and up to 4.2 million. And we did this at an angle of inclination of 15 degrees. And the reason for that is it allows, with our stationary system, the wake actually sort of holds fairly still within the field of view, which after we got all this junk in the tow tank was a little difficult to move around. So we ended up changing the angle of attack, but still within the range of interest. And the model was untripped for this, and we were able to take wake measurements down to about 5 body lengths. So for the upcoming experiments, we're going to start these in the large recirculating water tunnel, which has a test section of 0.4 meters by 0.4 meters, about 16 inches by 16 inches. And we can get a maximum speed of about 7.5 meters a second in there. So we'll set up the stereo PIV system. We're going to conduct the experiments on an acrylic body that is as smooth as we can make it and untripped to begin with. And then the idea is to have a 3D printable to a high degree of fidelity nose cone that we put on that with potential tripping mechanisms. And also, if there's time inclination, we might also consider some approach to roughness there. And depending on what that might look like, we may also port that out into the larger scale testing that goes on in the towing tank. And so to follow up with the work that I just described in the near term, we, as all of these experimental designs, we are sort of challenged by getting the model large enough to get a high Reynolds number and small enough to not have considerable weapons. Can you give me a minute, please? I'll be right with you. Sorry about that. So the idea would be that the model would be about 0.25 to 0.3 meters. Unfortunately, we probably won't be able to hit 3 million, which is the lowest rung on the test matrix for the LCC test, but I think we can reasonably get 2 million, and we can certainly see how it goes from there. Because it's small and it's run by 1 or 2 people, we can probably do a pretty considerable test matrix in there. And we can do measurements along the entirety of the body in both lateral and longitudinal cross sections. And you can see the PIV setup that we have, but we certainly have been in discussions about either borrowing or otherwise acquiring some additional diagnostic capability that might improve our results. So moving on from that during the academic year and into the following summer, the idea would be to scale up into the towing tank tests and do tests at least 4.2 million, and depending on the configuration of the strut, etc., we can probably drive it up there. Typically, the limiting case here, I mean, our carriage system will do 10 meters a second, and on a large model, we can get quite large. But previous experience says that vibration sort of sullies the water before that time. So again, this is one of those things that we'll try, and then we'll try to step up as we go. But we can also look at a number of different angles of attack here. And the configuration shown here where we have the high-speed carriage and the low-speed carriage, we can actually move these apart by a fixed distance so we can get set measurements downstream. But if there is significant interest, and it sounds like there is, we can try also to move to on-body experiments to provide, something similar to what we're getting in the recirculating water channel. And then the other idea would be also to provide a test platform in this large towing tank to what Joe Katz and Philippe Bardet developed for their contributions to the project. And that is what I have.
So thank you very much. We actually have time for a question.
I have a question. Is there a specific, you limited by certain time of the year where we can come to your lab and test equipment because of the Naval Academy constraints?
Sure, and I've been meaning to give you a call to chat about this. So I've discussed this with the lab director, and his response was sort of one of these for a little bit while we navigate the COVID-19 issue, but generally speaking, what I think we should do is sit down with the lab director and the calendar and try to figure out what time works best for you. We typically operate in 2 to 3 week chunks, and there's some negotiation there. Summer is typically better, but there are I have a feeling that our normal requirements are going to be fairly limited this fall and spring. So that might be an opportunity for us to slide in there and maybe get a little more time. So I definitely look forward to that.